Oh.
All right, good morning, everyone. Another 8 o'clock. Don't give up, we still have 14 weeks to go. Okay. Before we start, may I know who is Lim Boon Tat? Is Lim Boon Tat here? Oh, okay. Okay, nice to meet you. Now I want to learn some names, but maybe it takes some time to learn all your names. One more person. An Yi Sun. Oh, okay. You have question for me, right? Today? Okay, like question. Okay. Today is a 2 hours lecture, so I'm not sure how fast it will go. Maybe we don't want to waste time. So let's get started. Okay, so before we start, I want to address some questions from last lecture. Oh, by the way, for the administration announcement, so I fixed Friday 1 to 3 for another office hour. Okay, Friday 1 to 3. And then the other one is, anyone remember what? For the other office hour? Thursday 10 to 12. Yeah, Thursday 10 to 12 is after this class. So 8 to 10 and then 10 to 12 will have an office hour if you want to find me in my office. If you look at my lecture notes, after I do some adjustment, there's some pink and not pink, purple comment. Okay, those are comment for you to see what I'm doing, and also I'll put some extra knowledge in there. Okay, so those extra knowledge maybe is not required for this course, but for your interest or my interest. Okay, and yeah. So if you want to further doing postdoc in AI, then you cannot avoid mathematical terms. Okay, they use mathematical terms to do face recognition and so on. Because you want to do with surface, then you need to deal with Riemannian manifold and so on. Okay. I know how many of you plan to pursue your study for master and PhD. Any one of you? Or don't know yet? Don't know yet. No plan yet. Okay. Never mind. Okay. So issue from last lecture. Oh, there's someone who asked me haven't come yet. Okay, never mind. I'll just address now. So issue from last lecture, first of all, is the orientation of interval. Okay, so last time we talked about this or semicircle. Right. Okay. So anyone can remember what's the parametric equation that describe a circle of radius 1 and center at 0? So I mean, okay. So this is a circle of radius 1, center at 0. Okay, so this one is very important. Later we will see actually what are you doing for this parametric curve here. Okay. Okay. So I need to specify my domain, right? So what's the domain for the right and left? Okay. So why, for example, we pick minus pi over 2 to pi for the green one instead of picking 3 pi over 2 to pi over 2. Okay. So if you look at the line between 3 pi over 2 and pi over 2 and minus pi over 2 between pi over 2, okay, let me just label it. So here's pi over 2 minus pi over 2 is equal to 3 pi over 2. Although they represent the same point, okay, but because of the sign here, okay, you see the sign problem here? So this number here is actually greater than pi over 2, right? So we are writing something like 4 greater than pi greater than 3. So this is not possible, right? That's why we pick the negative representative for that angle. Make sense? Okay. So because of this orientation of the interval, then we need to pick the appropriate angle. All right. Okay. Is everyone okay with this? Okay. No problem. Okay. So similarly, on the blue part, what angle should you pick? Over 2, 3 pi over 2 instead of minus pi over 2. Okay. So yeah, our orientation is small to big, cannot big to small. Okay, due to this sign here. Okay, small to big. Remember this example here. Okay, small to big, cannot be big to small. So this one is wrong. So far, okay. Yes, okay. So if I switch If I switch the orientation, then that's fine. Okay. But if you switch the orientation, then the direction also changes. So yeah. Okay, another thing is about there's a quick comment when we finish end of the lecture. So is the or tangent. Okay, I wrote something wrong for the vertical tangent. So vertical tangent, the gradient at that point actually approaching infinity. Okay, so how do you think about it? So for horizontal tangent is dy dx equal to 0. Okay, so if you can picture this, so dy dx equal to 0 is at somewhere here, right? I mean, if at sorry, to be precise, right? This should be as evaluated at a point. Okay, so let's take the point at 0, 0. Let's take the point at 0, 0. Otherwise, I can draw the horizontal line anywhere, right? Make sense? Okay, depend on which point I draw, then I will draw the horizontal line. Okay, if I say this point is for example, if I say this is a 0, 1 point, then I will draw it here. Make sense? Okay. Okay. So just look at 0, 0 point. So um so for D so for what to say? Okay, so if we slanted this dy dx, right? So this dy dx is 1. Okay. If we slanted more, you can see that this dy dx will be increasing. So on. So that's mean I'm looking at y equal to x, y equal to 2x. Okay. So this gradient supposed to be the yeah, the gradient of this function here. So when you get close to the vertical tangent, you'll see that it is actually increasing to infinity. Can everyone see it? Everyone see it? So dy dx equal to 1, dy dx equal to 2, and then 3, 4, 5, and it keep increasing until you reach this vertical tangent here. And then you can see the limit of dy dx approaching to infinity, getting great, bigger and bigger and bigger. Okay, so this is how you remember, I mean. Okay, any question? Any question? No? So far, okay. At the back, confused or not? The back, okay. Just ask if you think that which diagram not make sense, you should ask. Otherwise, yeah, very hard. Okay, and another question, another student asked me, what if dy dx, but the what? Eh? What did she ask? Okay, she asked dy dt dx dt is 0. What do you think? Why not? Uh, Wait, let me think. I think dy. Hello, 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 gone. Hello, hello, hello. Oh, why is it gone? I have to call IT. Hello, 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 hello. Uh, I'm not sure maybe dy dx doesn't exist, but if you're not changing over time for y direction, you're not changing over t for direction. Hello? The mic is not working. Okay, thank you. So yeah, what I thought is it should be a point. Yeah, it doesn't move. Huh? Yeah, just a point. So you are not moving over time. Yeah. No dy dx. Or defined to be zero, maybe. Yeah. Okay. So it should be just a point. Okay. Good. So I put on the tutorial question, right? It's just a few for you to practice, but I don't think it's enough. So if you have more time, you should do related question and then yeah, do related questions. Okay. I just pick one of the representative from each category if you can see it. Yeah. So if you can do more. Do the odd number first because odd number have the solution. Then after you do the odd number, you can do the even number. Okay. Okay. I don't know. When you design computer, right? Every time like that one. Last time also like this. The screen doesn't work. And then I ask the person come and then suddenly it works. There's like quantum things happening. Quantum entanglement. Okay. Uh, okay. Any more? No more. We will start today's content. Okay, so we will continue with this calculus with parametric curve before we jump into polar coordinate. So last time we end at finding the arc length. So we find the length of the curve by approximating portion of the curve and then taking the integral, which is taking the infinite, taking the limit of the curve, portion of the curve. And then next, we will look at the area under the parametric curve. Okay, let's say you're given a parametric curve, you have x, y as a function of t. So how you express the area under this parametric curve? So to give you a schematic diagram, so let's have a parametric curve in our mind first. So what do I mean by area under this curve? So the area under the curve is obvious. So let's take this as sorry. Let's label our curve first. So t equals to a at this point. T equals to b. See, is this stop again? Hello, hello. Oh, okay, okay, okay. Y and x. So so area under the curve is everything under the curve up to the x-axis. Okay. Okay. Yeah. So how should I put it? So maybe we will put this y. Am I gone again, right? Hello, 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 hello. Hello, hello. Okay. Um. So I hello. Yeah, the mic gone again. Hello, hello. Sorry. Hello, hello, hello. Okay. Do you know what point is this? Sorry. Do you know what point at the bottom here? Yep. So it's a FA and FB. Okay. All right. So maybe we can write this curve in term of x. Okay, like what we did for the circle case. Right. Circle case, we can write y in terms of x. Supposedly. So what's the area here? Okay. So the area should be equal to integrating x component from FA to FB, okay, on y and then dx. Right. Notice that this function here doesn't have t variable, right? But our y and x are in t variable. Okay, so how to derive? So a so we know that y is equal to gt, okay, x is equal to ft, right? So what's dx? So you need to do the chain rule. So dx is equal to f prime t times dt. Okay, so chain rule. So let me put chain rule here by chain rule. Okay, so by chain rule, we can replace everything in terms of t. Y is what? Gt. Dx is f prime t dt. Okay, so how about the domain? How does the domain change? So you are integrating a to b. So when x is fa, fb. Oh, sorry. Now I somehow work, but I take out then it doesn't work. Don't know, not enough battery or what. Yeah, but later I talk for a while, then it will go. It will be gone.
So, but after you got issue, you just call me back.
Just now I already call another one here.
Okay. So now it's okay. Cannot check.
Can I check? But I think it will come back in 5 minutes.
Whenever I wait for him.
Are you? Okay. Okay. So yeah, okay. So if you change the domain of x to t, it's actually starting from a to b. Right? Okay. So in this case here, you can find your area in terms of the function in t. Okay, makes sense. Can we skip examples for this one? Or you want to do one example? Huh? Want to do example? Okay. Let's do example. Okay. So let's bring this formula with us first. Okay. So the question said, let's find the area under one arc of the cycloid. Okay. So you given parametric equation. Okay. And then you want to find the shaded area, which is the blue area. Okay. So you are given f. Oh, sorry. We call it f, right? Yeah. FA. So you get from 0 to 2 pi r. Okay. So you start from 0 to 2 pi r. So this is your FA. Okay. So your x, how should I write it? So your x is going from 0 to 2 pi r. So in this case, what's your t? Can you find your t? Okay, so the guess is 0 to 2 pi. So how to find it? So you let your x be the given parametric equation, okay? And then when x equals 0, sorry, we use theta, right? So we should use theta then. Okay, you can see that we slowly switch our time to angle now. Okay. Okay, so I think it's slowly going. Okay. Okay. When x equals 0, hello, x equals 0, x equals 0, okay, what do you get? Hello, 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 hello. Okay. My mind scared of the IT person. So if the IT person come, then okay. So you get 0 equals to r theta sine theta, right? Is it right? Huh? Oh, sorry, r sine theta, sorry. R sine theta. Okay. Okay, sorry. Yeah. So in this case, we can cancel r and then we get sine theta equals to theta, right? So when is sine theta equal to theta? Theta equal to 0, and then I think got the just 0, right? Yeah, just 0. Yeah. Okay. Because if you look at the the uh, the sine curve, okay? So only when sine 0, only when sine 0 is equal to 0. Okay. How about 2 pi? So when s equals to 2 pi, okay, then uh then what? 2 pi is equal to r times theta over sine. Okay. So how to get it? So you get what? Sine pi equals to 2 pi over r. Let me see. Let me see. What is equal to 2 pi? Sorry. Yeah. That's why I confused why there's an extra r here. So the reason they designed this question, they want to get you to get rid of the r. So we can get rid of the r. And then we will get theta minus pi, is it? So we'll get theta minus pi here. Is that right? Okay. So when is the theta, when you take sine is equal to theta minus 2 pi? Okay. So you can plug theta equals to 2 pi and then try and check that this actually holds. Okay. So if you ask me how to see this, I'll see it as a translation of this this simple case here. Is a translation, okay? Because minus 2 pi. Okay, because previously other point doesn't satisfy sine theta equals to 2 pi, equal to pi, sorry, sine theta equals to theta, but after translation, 2 pi satisfy this equation instead of 0. Okay, is that okay? Please ask if you have any question. Okay, so now we found our A and B. We have G theta, right? It's just R1 minus cos theta. Okay, but what is F prime theta here? So we need to take X prime with respect to theta, which we get R, yeah, R1 minus cos theta times d theta. So instead of d, okay. Gone already. Hello? So f prime theta, okay, f prime theta times d theta, right? So let's substitute it in. So we get r time 1 minus cos theta d theta, right? Is everyone following? Is everyone following? Following? Okay. So to integrate this, you guys do it now. Let's do it together. See, what do you get? This is just a normal integration of trigonometric equation. So let me reduce this. Okay. So okay, so usually when we integrate this kind of multiplication of function, right, we will we will uh, break we will break it. I don't know, it's maybe not enough battery. I don't know. Yeah. Okay, so normally we will multiply into expand the term first so that we can integrate term by term. Okay, so you can see that the first term is 1, second term is 2 cos theta. Okay, we still can integrate. But how about power of cos? Okay, we can't really do that. So we need to make it into to cos n pi n theta, something like that. Okay, so we can use the trigonometric identities. Okay, we don't really how to integrate power of trigonometry, but we can make it into another trigonometry function. So we can use this trigonometry identity, which is oh, okay. Hello, hello. Okay. Okay, so we use this trigonometry identities, which is cos square theta equals to cos 2 theta over 2. Okay, so cos 2 theta is another trigonometry function, and then with a different period. So we can differentiate this now. So okay, let us substitute it in first. Okay. Yeah. Okay. So can you do the integration now? Yeah. Okay. So what do you get? You get theta on the first term. Okay. And then you integrate cos, you get sine. And then you integrate half, you get theta over 2. And then you integrate cos 2 theta, you become sine 2 theta, but you need to bring the 2 out because it's like the chain rule the other way. So what's your A and B just now we found is 0 and 2 pi. So we should replace our A and B and with 0 and 2. 0 and 2 pi. Okay. So what's this whole thing here? maybe I straight away give you the result is 2 pi plus pi, which is 3 pi r squared. So yeah, so you can see that they pick very cleverly these 2 pi r here so that you can get rid of this r. So maybe in real case, right, you need to deal with different r. Yeah. Okay. Any question on this example? No? Okay, next. Next is the surface area. Okay, so surface area is the area obtained by revolving the parametric curves about the x-axis. So in your mind, you should imagine there's a curve, okay, and then revolving around the x-axis. So it means something like this. So you take this line and then you revolve. It's like a fan, right? It's a fan. You revolve around the axis. So this one is not symmetric enough. So let me move it out. This case, I move this axis out. Okay. So revolving around the x-axis. So use x-axis as the center, then you revolve. And then when you revolve, then you will draw one surface. Okay. Yeah. Okay. Okay. Yeah. So how should I start? Okay. So from here, right, you can see that what do you have? Okay. When you revolve a circle, right? When you revolve a circle, what is the circumference? What's the circumference? Yeah, what's the circumference? Correct. Yeah. What's the formula for the circumference of a circle? Circumference of pi 2 pi r. Okay. So I'm asking about this I'm asking about how long is this part? Okay. So this part is 2 pi r. Okay. So what's the radius here? Y. Okay, very good. This is 2 pi. Yeah, right. So here is 2 pi y. Okay. Then how long is that curve? Actually, we will call it a dx. Okay. So like depend on how far you want to see. Like how is the whole thing? Okay. Because it's not straight, right? Yeah. If it is straight, then it's just x. If it is not straight, then we'll look at the small pieces of it. Okay. Okay. So let me put this formula down. So actually this x is different integrating from a to b dx. Okay. But we also know how to integrate along this curve is at the arc length. Okay. So we just replace the dx with the arc length. Because this length here doesn't depend on time yet. So we need to make it depending on time, which is the arc length we use or we defined last time. Okay. So this is the whole formula. Uh, so this explains why the area of surface revolving around the x-axis include the 2 pi factors in. Okay, because you are drawing a circle. Okay, using the curve. Okay. So similarly, you can also draw around y-axis. So you just need to the uh, change the variable y to x. Okay. So let me write down. So similarly, you can revolve about y-axis. Okay. So this case, you will get different domain. Okay, you need to check what domain you have, and then on the different variable, which is x now, and then the same outline. Okay. You want an example, or we can skip this example? Skip. Okay, because it's just really the skill here. What the skill needed? Differentiate your curve with respect to time. Differentiate x with respect to time. Okay, and then take square root, and then multiply the function together, integrate over t. Okay, you can see that here y, right? Okay, should I do one? Do one. Okay. Do one. Okay, slowly we will get faster because a lot of things we need to cover. Okay, let's do one. Okay, do one. Okay, so a sphere of radius r is obtained by rotating the semicircle. So let's draw it up. A sphere rotating a semicircle, r cos theta, y equals to r sin theta, from 0 to pi. So it's something here, somewhere here. And then the radius is r. Okay. So you rotate around the x-axis, then you can get the whole sphere out. Can you imagine? You take a semicircle and then you revolve around x-axis, then you get a sphere. Okay. So now we want to compute the surface area of a sphere. First of all, do anyone remember what's the surface area of a sphere is? 4 pi r squared. Okay. So this is the formula you remember before. So we're trying to derive this formula again. Okay. So so in this case, our time is going from 0 to pi, right? And then 2 pi times y. So what do you mean by y? Y here actually is a depend on t. Okay. So what is y? Is r sine theta. Okay. I think we have computed dx, dt, and dy dt a few times already. So ds dt is minus r sine theta, and then dy dt is r cos theta squared d theta. Okay. So altogether we will get what? 2 pi r sine theta square root r squared d theta. Right? Okay. Using trigonometric identity again. Identity. So next, we have what? We have 2 pi r square integrating sine theta, sine t dt. Okay, so what do you get? I get minus cos, is it? Minus cos t times 0. So what do you get? A cos pi is -1, cos 0 is 1. Okay, make sure I put the right -1, right? Okay, so we get 4 pi square. Okay, is it okay? Everyone follow? Okay. So yeah. Okay, next. This one. So this is a cycloid question again. So this one we will left as exercise. Last for the first lecture, I also did this exercise in my lecture note. If you already have a look. So just now we already did area exercise for cycloid, and then this one is a surface area for cycloid exercise. Okay. Okay. Next. Okay. Before going to this polar coordinate, I want you to think about something. Okay. Let me draw. Sorry. This one. Okay. So when the first example we explain, we talk about this circle, right? Okay. We somehow accustom ourselves to like 0, pi, pi over 2, pi, and 3 pi over 2. Okay. So you can imagine that when we are looking at the xy coordinate, okay, we're actually looking at like this single point here. Okay, so we like split our spaces into point or rectangular partition. Right? Make sense? Okay, every point defined by this xy. But we also can stratify our space using circles. Right? So you can use a circle that grow with 0 radius and then grow around this uh, center, and then taking all radius of all kind, and then we also can fill this space. Okay, so this is those. So in this case, we will call it a polar. In the second case, in the first case, we will call it the Cartesian form or Cartesian coordinate also work. Okay. So, what did we do? Let me see. So, what variable we change is we make x into r cos theta because we want to consider all the radius, and then y is equal to r sine theta. So this is the I would say this is the relation between the Cartesian coordinate and the polar coordinate. Okay. So every x and y, we can find a point on the circle to describe x, y. Okay, make sense? So we put this R is because we need to know which circle it lies. Okay, maybe I draw another point here. So maybe let me think how should I do it. Okay, so let's say this is a 1. This is a 1 here. Okay, we got a 1, 1 here. Okay, so actually this 1, 1 will lie on a circle. Okay, so what circle it lies on? Is a circle with radius? I don't think so. Is it 1? What's the radius here? Square root 2. Okay, so it's on a circle with square root 2. Okay, circle of radius root 2. Okay, so it will be, if this is a root 2 here, then you lie somewhere here. Okay, okay, okay. So mathematically, you need to memorize this part here. Okay, how you go from x, y to r cos theta and sine theta. Similarly, you also can go backward. Okay, if I give you r and theta, you also can go backward. So okay, let's write out what do we do here. So we can go from xy to r theta. Okay, we can go from r theta to xy. Okay, otherwise this change of coordinate doesn't work if you cannot go backward and forward. Okay, so we also can go backward. Anyone have any idea how to go backward? The key is the trig identity again. Okay, trigonometry identity. Okay, so you can do x squared plus y squared. Okay, what do you get? Get r squared. Okay, so from x and y, you can compute r again. How about theta? How to get theta? Okay, so you can divide the two. Okay, so you divide the two. So how to divide? Y over x is better. Then you get tangent theta. Okay, so from xy, you can get theta back again. Okay, so these two is how you go forward and backward between Cartesian form and polar form. Okay, make sense? Okay. So since we are lying inside polar coordinate, so we can use radius and theta. So you should think of which circle I'm in. Yeah. Radius what? Radius 2, then it's on the radius 2 circle. And theta will tell you which point on the circle you lie. Okay. Okay. So you can see this picture here. So let's say we got this r theta point. Okay. So this means it lies on a circle with radius r. Okay, maybe it's longer a bit because you need to turn it. And then the angle is theta, right? So let me draw an arc for you to okay. So the other point on the opposite, you can take minus r theta. Okay, this one is very important because you have to know how to switch from the positive r to negative r. Okay. Or this one is actually equals to r theta plus pi. Okay, so this is by definition actually. This is by definition. Okay, minus r. Because r is a radius, right? Radius cannot be negative, right? Yeah, radius cannot be negative. There's no negative circle. Okay. If it is negative, how you see the circle? Okay. So actually this is defined by, so the negative r theta is defined by r theta plus pi. Okay. So this theta here actually lies in the first quadrant. Okay, lie in the first quadrant here, the basic angle. Either you change the angle, okay, you don't change the r, or you change the r, you don't change the basic angle. Okay. Yeah, this one is quite important. You need to get your head around this. Okay. Sometimes it's not easy, but try and do it. Okay, so the one thing about this polar coordinate is you can represent the same point using different angle. Okay, like what we mentioned yesterday, if you go around clockwise or anti-clockwise, they represent the same point. Or you go a few times, a full turn around the circle and then come back again with the same angle, you still get the same point. Okay. And then the last thing is this you need to get your head around with this minus r minus r. Yeah. So when you have a minus radius here, right, make sure your theta lies in the okay, let me put this note warning here. So this theta lies in the first quadrant. The first quadrant. So meaning theta is greater or equal to 0 and then less than or equal to pi. Okay. When you use minus r, when okay, let me write more. When involving negative radius. The okay. Ah. Okay.
When analyzing the first and second word.
Oh, sorry. Oh, sorry. I just write wrong. Sorry. This is pi over 2. Let me think. No. Should be pi. Sorry. Yeah, should be pi. So yeah. So first and second allow. Yeah. First and second. Yeah. First and second. Okay. Because why? Because what? Let me think. Yeah. Mm. Yeah. Yeah, you're right. Yeah, only go below the axis. Yeah, x-axis is negative. Yes, that's right. So usually we will call the top one is a positive half plane, and the bottom one is a negative half plane. Yeah, you're right. So a positive half plane contain first quadrant and second quadrant. Negative half plane contain third and fourth. Okay. You want to take a break? Take a break. Let's break for 10 minutes. At 9:05. Hey.
Ask the question.
Yeah.
About, yeah, I didn't take this, but
Yeah, never. Okay, which one?
So
What do you want to check?
the client,
Cycloid?
uh,
What?
sorry, let me have a check. Maybe at maybe at this one.
Oh, this one. Okay.
Yes, I want to know
Mm.
also, or if this part job is to approve this one.
Yeah.
Oh, but okay, but actually, no. I just my other point of view is that we can see from this distance because it's 0 to 2 pi r.
Yeah.
We can directly implies that theta is ranged from the 0 to 2 pi.
How?
Oh, this is the distance, right? The circle. Yes, the circle row, and the distance is it's
But this is a different how to say?
this is sorry, pardon my English, pardon my poor English. This is a whole plywood, right? So it means the circle goes a whole
Yeah, but
round, right? So the distance is 周长 is I don't know.
yeah, I know what you're saying. Let me think. Okay, yeah, conceptually is correct, but how do you show it mathematically? Because yeah.
So
Conceptually, it's correct.
So I think we don't need this one to prove the theta. I don't know. It's another way. It's the
I'm not sure. It's not
Mathematical.
obvious to me.
oh okay here say this one OT is this one, right?
Yeah. Why is it that one? Why is it that one? Do you know why?
Because the roller I don't know how to say a wheel, right? A wheel rolling, and the distance E over it is just it's this is the you give us the question.
Yeah. That's why I'm asking you whether you understand or not.
Yes,
Because I think quite. I mean, for you,
I can understand you, but I can express myself because of my first.
No. I mean,
Other than it, the distance refers
很远
to the arcness. Okay. But then,
okay. Let's think about my explanation.
oh yeah.
Okay. So the circle start from here, right? So
Yes.
from this bottom point here. Okay.
Yes.
So and then you roll like this. Right, you roll. Okay. So when you roll over here,
Mhm.
right? So how far have you traveled? So your point go from here to here.
Mm.
And when you trace your path, you're also starting from here to here. Okay. So that's why this line here will match to this line. Okay, think about this line. Think about this. So why? Okay, let me give you a scenario. Okay, so I give you 2 pieces of string. Okay, these are 2 different strings, but I also can draw maybe something like this. Yeah, maybe not that long, maybe shorter a bit. But there's still different string. Maybe I draw it shorter. I cannot do it like super clear to you, but I also can draw a
Yes.
but their length may be different. So there's no reason why they must be the same at first. You get what I mean? So I mean there's no
I mean this is Clyde or not? This one is Clyde.
cycloid, you mean?
Oh, cycle. Oh, sorry.
Yeah, true. So only cycloid can does this.
Yes.
Yeah.
And
so
the question already gave us is cycloid.
Yeah. I mean, I mean, how to say? I mean, conceptually is correct, but you need to show it mathematically.
Oh, doesn't it obvious to see it? Isn't it? I don't know. It already given.
Okay. If you start from definition, then I think it's obvious.
Oh, okay.
Yeah, from definition it's obvious,
So
but
just to make sure it's 100% right.
I mean, just show it from mathematical point.
Okay.
Yeah.
So
I mean, this method, right? The method I showed just now will work for any cases.
Yes.
So I draw anything to you, and I give you 2 parametric curve, and then you have these 2 endpoints. Okay, go and find what is the theta.
Oh, okay.
Yeah. I mean, this one would generally.
Sure. So should we advise on the whole process during the exam? I mean,
Yeah. I think so. Yeah.
so we should, right?
Yeah. Because it's a skill for you to find what's the time given a point in XY, you need to find the time for me.
Okay. Thank you.
Give a time, you also need to find an XY for me.
Okay. Okay. Wait. Can we go back that question? Go back that question. So we should do this part during the exam.
Yeah, better. Yeah.
Okay. Thank you. Okay. Thank you.
放那个。
那个ですか？那我的 data 是从这个 point 开始。
你对，所以其实我们要切成，对， 所以你其实我们是要切，给我看一下，哎，跑到哪里去了？天哪！对，那个 half plane 其实不可以 include 那个 nice side，为什么不见了？对，然后你继续说。对啊，
明白是来，
Yeah
data 从这里下，可是我反过来这里，就还是
也可以那样理解啊，所以呢有什么问题？再说一次，出一个什么问题？比如他给你一个减 r 滴答的话，他那个滴答一定不可以动到这个拍，然后是在 second 跟 first 里面。
很正牌啊，但我还是第一个从这里开始，
拍就有一个拍，我没有这样打。
那一个小
angle
但是 angle 倒过来这里的话，从这里开始啊，
没有 angle 一定要从零开始。
要从零，
对，所以我们才所以我们才分辨到这个拍的，可以吗？可以 get 到吗。然后在这里啊，可以 get 到吗。
到这里这样子，或者是哪个地方
negative r，你是说如果这一个的话，它 negative r 活在哪里？是不是？OK，所以这个 negative r，OK 叫它 theta 3了，所以它就跑来这里了。
下一个是
对，减就是一个 straight line。OK， 好，等一下我再说。你有？
我是不在那个模组上面，
你不在 model 上面？
对，就是后面加这个，
但是我有。
在这边，
哦，你不是
我是才加的，
不是
你不是那个？
对，
没有，是他的性质那边
哦，你等一下，你的名字在这个下面。
对，没有，
你第一天他立的
第一天没有，
为什么？
为什么？
因为没有我名字。
你要加进去。
OK，
对
刚好要
OK，
这是我最近还是
不用紧，我会加你进来。有问题吗？还是
有 OK， 我假设啊，像这边啊，
在那边很亮，
假设啊，我要没有，就是假设是这条线啊，我 represent 这条线啊，我要写成哪个地方 radius 啊？
对，
就是假设你看我一个哪个地方，
你要反两个哈。
啊，就我不要理这个蓝色线啊，就真的我要 represent 这个黑色线，这样我的底大是从这里开始算还是怎样？
等下给我想下哈。我
有没有跟哪个地方？
慢点回复你没有？
可以，
可能下一堂课或者我 email，如果都要听的话，我就下一堂课再讲。
对，也是可以啊，我就是我写成哪个地方，就是如果我 first column 我写成哪个地方也是可以，也是。
我确定一下，我想清楚的。
OK，
我等下我会跟你讲。OK， 可以，我觉得是可以，但是我要想清楚一下。
好，因为你这样子讲的话，
对，
就你这边可以写成negative，没有理由自己 positive 不可以写成negative，这是有道理。就好像
是可以是吗？
很难讲，等下先，我要。OK， 我会讲。
见了
OK，
那个可以是那个是。
Hello. Okay. Yeah. So this positive half plane, right? Actually, we don't include. Okay. So let me make something smaller. So we have one more hour, right? Have to press Swift. Okay, so actually, starting from this pi line, right? Starting from here, okay. So let me put. So let us be precise, okay? Okay, I like you very practical. Huh? So let's say we have this point here as R0. Make sense? Any R you like, as long as lying on that line. Okay. Hey, sorry, I need to pass this sign before you. Okay, so let's take this R0. So maybe I make another color so it's easier. Okay. So really, starting here, you can already start with minus R0. Okay, so really we are starting positive half plane. Maybe we don't include this. Okay, so R0 is the same as minus R0. Is also the same as R pi. Is it making sense or not? Making sense? Making sense? Okay. Okay. So one of you asked whether is it possible to express something on the top with minus R? Is this possible to express something at the top? Why not? Huh? No need? No need or what? No need. Why no need? Oh, okay. I know. I mean, why? No. It's not about no. Yeah. I mean, I mean, yeah. Sometimes no need, but we want to know whether it can be done or not. How? Obtuse angle. What do you mean?
Plus 180 or plus 5.
You mean something like this?
Or negative 5.
Yeah. Okay. Correct. So, okay. So, yeah, that's right. So you just put minus on this guy here, right? Then it will jump back again. So minus R is for you to like go from the left. I mean, I'll say, if you look at one line, okay. So in your mind, you should imagine a circle. You should imagine a circle. Wait. Imagine a circle. Imagine a circle, and then you have a line slicing, or so you have a line connecting the point between two points on the sphere, and then the R and minus R will be letting you to go from one side to the other side. Okay, that's all. Okay, makes sense. Okay, yeah. Negative theta. Or you want negative theta. So negative theta will mean turning from the other side, which is clockwise. Yeah, you also can. You also can. Yeah, you also can. Okay. So far, any more question? No more. Okay. Let's continue. Okay, let's continue. Okay, continue. Okay, so for example, let's try and convert between polar coordinates and Cartesian coordinate. Okay. So for this, this is a polar coordinate. Can you translate it into a Cartesian coordinate? Okay, so that means this point lies in where? It lies in a circle, okay, with a radius 4, which has a pi over 6 angle. Okay, so what's the xy coordinate here? Okay, x is equal to r cos theta. In this case is 4 cos pi over 6. Okay, so what's this? 2√3. Okay, how about r sine theta? You will get 4 times sine over 6, which is 2. Okay, so it is actually the 2 square root 2 square root 3 and 2. Okay, so you can plot 2 square root 3 here and then 2 here. Okay, okay, so far so good. Then similarly, you can go backward. Okay, so this one we will just skip it. Okay, next, similarly, we can just use r and theta to describe the function. Okay, we're not using x and y anymore. We also can use radius and theta to describe a function. Sometimes it's easier if your graph is polar. Okay, what do I mean polar? So for example, let's sketch the graph of polar curve of r equals to 2. Okay. So in this case, you can sketch graph function now. Okay. You can sketch function now. But in xy, it is not a function. But in r and theta, it becomes a function. Okay. So how to sketch r equals to 2 curve? So you need two ingredients, right? R and theta. Any condition on theta or not? Any condition on theta? No. Okay. So that means everything that have radius 2 is actually your point. Okay. So if you take all these points together, you will form a okay. 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 How about the polar curve theta equals to 1? Any condition on R or not? Any condition on R? For polar curve theta equals to 1? No, right? Okay. So the only condition is the angle. Okay, the angle is 1. Okay. So OR you need to consider. So you extend even the -1 you also consider. Minus radius. Okay. About this curve, this graph here. So how about r equals to 2 cos theta? Okay. One way you can do it is you first plug in some value, and then you try to plot this value on the curve first, right? And then you try to link them together. Okay. But there's another way to see this. Okay. So if you play enough with this equation here, you can actually see it satisfies some circle equation in terms of xy. Okay. So for example, let me see. Let me see. Let me see what do we have. So r equals to 2 cos theta. Okay. So you can find that r squared is equal to actually 2. What am I doing here? What is r squared? It's 4 cos square theta, is it? I'm not sure it's helpful or not, but let's try out. So let's remind ourselves what is the change of variable here. Okay, so under this change of variable, we can see that x squared plus y squared is equal to okay. So far okay. Okay. This r squared y seems a bit weird. Okay, so maybe this r squared is not very helpful. If we put this as cos theta times r, maybe will be a little bit more helpful. Why? Because I want to turn my r back to x. Okay, so this one is not very helpful. Then this one will be more. Why? Because can relate back. Okay. So in this case, we have an expression of r squared relating back to xy now. So r squared is what? It's actually sorry. This should be 2x, right? Okay, to be precise, so that I don't do sorry. So I'll get 2 times r cos theta, okay, which is equal to 2x. Okay, so now it's more useful because we can relate back to x1. So that this equation here, we will get only x and y. Okay, so from here, yesterday, Ang also asked me this question, right? Can we stop here? Okay, you can stop here, but if you can change it to some useful equation that you can see is better. What? Yeah? Nothing? Okay. Anything? My square missing? Okay. So if you can realize this as some geometry, right, that would be more useful. Okay. So in this case here, actually we can turn this into a circle equation. Okay. So anyone know how to turn it into a circle equation? +1. Is it enough? +1 minus 1, right? +1 or minus 1? -1. +1. +1. Okay. So actually +1 minus 1, you did nothing to the equation, and then I will move the 1 to the side. Okay. So why do we want to +1? Why we want the +1? Because we want to factorize the x. Okay, so we want to factorize the x. So if we want to do the factorization, we get x minus 1 squared plus x squared. Okay, so this is the general form of a circle. Okay, with center at 1, 0, with radius 1. Okay, so the center here should be 0. Zoom a bit. Okay, zoom working or zoom diagram? Okay. Okay, ma. Okay. Yeah. Continue. Okay. So you can see that this two here, right, somehow shift the circle, right? Okay, this two here somehow shift the circle. So there are few things we can adjust here. We also can adjust this theta here. Maybe we can change this to some n theta, and then we can also shift it by some number. Okay, we're going to study all what will happen if we did all these things. Okay. Okay already or not? Okay. Okay, continue. So next, if we consider a scale cos theta, okay, or plus together I shift it, okay, we will get some graph called the limaçons. Okay, it's a French word. You can go and find how to pronounce it. Limaçon, which is a word for snail. Okay, why we name it French? Most probably is found by French at first. Okay. So why is it like snail? So we can look at a few examples here. So if we shift by 2 cos theta, then you will see that this part here get a little bit flattened, like a tire punctured. Okay. And if you shift less, then you can see that this actually go a little bit inside. Okay. So this part here go inside more. And then it go and spiral around. Okay? When you take less and less. And then if you don't shift it, then just now we see that it's another circle again. Okay. Kind of weird. So you can also see that it's a bit like hard sometimes. Okay. So when A equals to B, in this case here, when A equals to B, it is called is also called a cardioid. Okay. Because it looks like hard. Okay. Okay. So let's see how to plot this cardioid here. Okay. So if you're gonna plot this R against theta, okay. So this is a sine curve shifted by 1 up. Okay. So if you plot R against theta, you will get this curve here. Okay. It's a shift, it's a sine theta shifted by 1 up. Okay. So far, so good. Okay. Let's say how we plot it in the XY plane. Okay. In the Cartesian, okay, I should say Cartesian product. So, yeah, Cartesian coordinate. So this is a polar coordinate. Let me make this clear. So this is a polar coordinate. This is a Cartesian coordinate. Okay. So you can see that when it is angle 0, it is radius 1. Okay. So when it is angle 0, it is at radius 1. Okay. And then it keep growing up to the angle pi over 2, which is radius 2. So at this angle here, it will touch the point radius 2. Okay. And then you keep going, see what happened at pi. Okay. When it's at pi, it go back to 1 again. Okay. So it's kind of symmetric across this y-axis here. So you can continue to pi. And then what happened after pi? Keep reducing to 0 up to 3 pi over 2. Okay. So when you go from pi to 3 pi over 2, the radius decreases. Okay, the radius decreases until it reaches 0. Okay. And then go from 0, it start growing back to 1 again. Okay, so from 0 going back to 1. So everything is symmetric because this sign is also symmetric. So you get this half. So you get a new Valentine gift. Okay. Okay, so you get this. Okay, so in this case, if I give you any shifted graph, right, you should able to follow this procedure and then plot out the limit zone, the snail. Okay. Any question, problem? Sorry. Upper one should be Cartesian coordinate. Okay. Yeah, depend on how you see it. You mean this one, like you mean like this? Let me think. Yeah, depend on how you see. Yeah. Yeah, I think it's right. I think this one is better because yeah. Okay. Yeah. I mean okay, maybe we make this definition the precise, then we will fix which one we will call Cartesian coordinate or which one is called polar coordinate. After we make the definition precise, because maybe we think of a different definition, so we have different opinion of which one is called polar, which one is called Cartesian. Okay. Next time we will try to fix this. We should fix that as well. Okay. Polar equation of the form. Okay. Now let's say we want to adjust this theta here. Okay. We put an n inside this theta here. Okay. And then it will give us something called the roses. I'm not sure why quite romantic for this topic here. It's called roses. And the rose has n leaves. If n is odd, you have n leaves. If n is even, you have 2 n leaves. Have anyone of you here studied chemistry before? Yeah, in secondary school or high school? No, never. Huh? What? Okay, so if you studied chemistry before, these are also like the orbitals of the electron. Okay, so how to sketch this rose? Okay, let's see how to sketch this rose. Okay, similarly, we start with Rose equation. In this case, we have r equals to cos 2 theta. Okay, so theta here will increase or decrease the period. Increase or decrease the period. Increase the period. Okay, so you have 2 full cos cycle here. Okay, between 0 to 2 pi. Actually, I found your class is a bit high. I don't know, but I feel like a bit high. So, okay, so you have 2 full cycle here. So how to make this 2 full cycle into roses? Okay. So similarly, we start with 0. Okay. At 0, you have radius 1. Okay. So at 0, we have radius 1. And then up to pi over 4, the radius decrease to 0. So along this angle here, the radius will decrease to 0. Okay. And with the same basic angle, the radius go to negative. Okay. So that means you need to go to the negative half plane. Okay. So you start from the same basic angle, you go to the negative half plane, and then you keep continue increasing up to -1. So you keep increasing up to -1. And then stop at where? Pi over 2. Okay, so the basic angle of pi over 2 is this line. So negative r will be going to the other side. So you stop at here. Okay. So maybe I also draw another diagram at the side. So you will see the process. Although there's a 1, 2, 3 there. So you go downwards. Okay. And then you go backward again. Up to 3 pi over 4. Okay. So here already draw out what's the line for 3 pi over 4. So you keep decreasing. So you imagine there's a circle. You keep decreasing the radius until you reach 0. Okay, so you go up. Okay, maybe a bit ugly. Back to 0. Okay, and then what? This is still lying in the first and 2 quadrant, right? So but the radius become positive. So you keep growing up to 1 and stop at pi. So you go where? So you grow to 1 and then stop at pi. Okay. What next? So after pi, it is positive. Okay, it is positive, but your angle lie in the 3rd quadrant. Okay, so it is positive, lie in the third quadrant, decreasing to 0. Okay, so it is still positive, but you go to the third quadrant and then go to 0. Okay, and then what's next? Here I think here's the key part already. So it's still the third quadrant angle, but negative radius. Okay, so although the line lies here for third quadrant angle, but you need to take negative of it. Okay, so that's why you go up. So it's like there's a double negative here. So you go up, and similarly, then you will go down. Right? Okay, go up, go up. Why go down? Because you decreasing to 0 again. Okay, because this lies in which quadrant? Fourth quadrant, but it is negative. So fourth quadrant negative, so go up. Okay, and then decreasing to 0, so decreasing to 0, and then what? Fourth quadrant increasing to 1 again. So fourth quadrant increasing to 1. Okay, so here is 1. Here is 1. Okay. So far, okay. Yeah. So this is the same principle if I change this n to anything. Okay, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay. Okay, next. This one, symmetry. Okay, there's a summary here, but maybe I'll leave you to read it. This is what we have discussed just now, and some of you point out. Okay. Next, we also can find tangent line to this polar curve. Okay, so how to derive this? How to derive this equation here? Okay, so maybe we derive a bit. So we have y equals to r cos theta. We also have sine. Sorry, this is sine, right? Okay, and then x is r cos theta. Okay, so just now we differentiate y and x with respect to t. Now we differentiate x and y with respect to theta. Okay, so what is dy theta? It is. Anyone have any idea what is this? No idea. Okay, so this is the product of two functions here. Okay, because you see r also dependent on theta. Okay, so actually both these functions depend on theta. So that means you need to use product rule. Okay, so you use product rule. So at first you get dr d theta times sine theta plus, so u prime v plus v prime u. So you get r cos theta. Okay. How about dx d theta? The same. Okay, the same method but different answer. Okay, so you get r plus r sine minus, yeah, correct, minus sine theta. Okay, so in this case, you can use your chain rule now. So dy dx equals to dy over d theta over ds over d theta. And then you just take these two, divide each other. So that's why you will see that there's a weird, not weird, yeah, quite weird, the summation term or the difference term inside your differentiation. It's actually coming from the product rule. Okay. So to compute it, you just find all the dr d theta and then plug in your sine theta r cos theta and then minus r. And is it 937? Okay, maybe we see how this formula works. Then I will leave one as a big exercise for you. Okay, so now we start with a polar curve now. Okay, r in terms of theta. Okay, r in terms of theta. And then we want to find a slope of a tangent line at pi over 3. Anyone remember what this graph is somehow look like? Wait, I mean what's the curve looks like? The limmason, okay, the snail, okay. Yeah, something like, I'm not sure this one is the other side or the same side. Okay, actually this A equals to B, right? So when A equals to B, this is actually a heart. Okay, so this is the heart. I feel like it's on this side for sine, but I will check again which side is it. Okay, then we want to find a slope at pi over 3. So pi over 3 will maybe something somewhere here. Okay, yeah. Okay, so what do we want to find? So we need to find what is dr d theta. Okay, so what's dr d theta in this case? Cosine theta. Yeah. Okay, good. So yeah, good. So we have cos theta times sine theta plus r. What's r? 1 plus sine theta. Good. Cos theta. And then repeat again. And then you need to expand this horrible thing. Okay. So let's just give you the end answer so you can go back and check if you like. So we got cos theta 1 plus 2 sine theta over 1 plus sine theta times 1 minus 2 sine theta. Okay. So now you want to evaluate this dy dx at pi over what? 6, is it? 3. So you just substitute in all the number. And can I not do that? Let you do it. The answer is -1. Okay. So the skill here is you need to know what's the dy dx on a polar curve, and then to calculate this polar curve, you need to know how to do differentiation. Okay, need to know how to substitute if you want to find at a specific point. Okay, so it's similar to what we did in the first lecture. Okay, is it okay? Okay. Okay. So next part is quite nice, but I will let it be an exercise. So this one left for exercise or homework, because this is really similar to what we did last time. We find the horizontal tangent, vertical tangent, and then we try to paste all of them up, and then we found the shape. I strongly suggest you try this yourself. Okay, I will release the answer afterward. Okay, it is really the same as what we did for XY coordinate, but for polar coordinate we have different formula. That's all. Yeah, so the end diagram is this. Yeah. Maybe there will be some issue when you find the vertical tangent, but we can address it if you guys want me to address. Okay, you try first. I let you try first. Then you can feedback to me what you think. Okay, so there's some list of polar curve you can get. All these are examples. Okay, next. Still next, yeah. Go a little bit further. Okay, let me see. Okay, maybe we'll stop at the area for this one. Okay, so area of sector. Does everyone remember what's the area of a sector is? Half times r squared theta. You know how to get this? Get it? Okay, so the area of the whole circle is 2 pi r, right? Okay. But sorry, pi r squared, crazy. So area of this one is circumference. Still live in the previous. Okay, pi r squared. So, but this is for a whole circle. Okay, you only want a fraction of it. Okay, so that means you are taking pi over 2 pi times pi r squared. Okay, that's why you got this 1/2 r squared. Okay, okay. So, but this one is for appropriate circle. Okay, nice circle. But what if your curve is like wavy? Okay, so to do that, we have to use integration again. Okay, we have to use integration. So you can see that for an area bounded by a polar curve, okay, starting from theta equals to A, okay, so theta equals to B, okay, but now is a curvy curve, okay, then the area is given by half integrating f theta squared. You can see that because here is constant, so it's r squared. But if your r change with the function, then we replace with f theta. Okay, and then we need to do integration now. Okay, because it's not constant, we need to do bit by bit, Okay. Okay, so let's try an example then. Let's try an example. So let's start with a limison. Okay, r equals to 2 plus cos theta. Okay, r equals to 2 plus 2 theta. So we want to find the area of the region inside this limison. So what's the domain? What's the domain for this limison? Yeah, what's the domain? What's the domain actually? Or area inside the, it's not the shaded, it's just inside. Okay, later we'll only do shaded. Okay, this one is inside. So inside is everything, right? So everything is 0 to 2 pi. Okay. So what's the formula? Let's remind us. So it's f theta squared. Okay. So now f theta is what? So f theta is 2 plus cos theta. Okay, so it's the 2 plus cos theta squared d theta. Right? Okay. So similarly, like what I told you just now, cos theta you cannot really, square of a trigonometric function you can't really do integration. Okay, so you need to expand them. Okay, expand them and get all the trigo function out. Okay, so you get 4 plus 4 cos theta plus cos square theta. See, power of cos come out again. So you need to use the formula to make it into a cos function, which is 1 plus cos 2 theta over 2. Okay, so for this cos, right, it is very helpful that you get a list of trigonometry identity beside you when you do this question. I think the textbook I gave you, they have the list of trigo identity. You just keep it beside you when you do this exercise. Okay, so at the end, what do you get? 4 theta plus 4 sine theta plus half theta plus sine 2 theta over 4. Okay, to save all the word, you can check back. We will get half 8 pi plus pi, which is now the 2 pi. Okay. Okay. Find the area of the shaded region. Okay, so now we want the shader region now. So this shader region is from where to where? From where to where? This shaded region from where to where? Good. From pi over 2 to pi. So you just change the integration domain to pi over 2 to pi. Okay. So everything inside is still the same. Okay. So you can just use what you have computed, which is this horrendous sum. Wait. This. I cannot paste. Okay, so I got pi over 2. Okay, to save time, we will get 9 over pi minus 2. Okay, so after you do all the substitution, you should get 9 over pi minus 2. So far, okay? Okay. So this is exactly the same principle for all the for all different polar curves. Okay, if you are interested enough, okay, you can try something, okay? You can try turn this polar graph into XY curve. Yes, turn polar graph into Cartesian graph. You turn the polar graph into a Cartesian graph, okay? And then you just pick, because in Cartesian graph, it is not, how to say, it's not a function, right? So you just pick the top part here and calculate the area multiplied by 2. See if you get the same answer or not. Yeah. Yeah. I think it's fun to do if you can try it out. Yeah, and then you will see that actually really you can go between XY curve and a polar curve. You should compute the same area. You should somehow get the pi out as well. I think the pi will appear in the XY graph before you integrate. Yeah. You can try. Let me know if you try. Okay. Yeah. After you try, let me know. Okay. Turn the polar graph into Cartesian graph, but it is not a function, right? So you restrict your domain to the top part. Because this is symmetric, you multiply by 2 to get the whole area. Okay. Make sense? Make sense? Okay. So in this case, if you want to find the shaded region, then you need to care about what is these 2 points here. This is 0, obviously, but what is this point? Yeah. So if you want to use the XY to compute. If any one of you tried out, please let me know. Okay, maybe we stop here for the day. Then we will see you next week. Hello. By the way, please hand me back my list. Where is it? Where is it? Still there? Here? Have you guys signed it? Sign it? You haven't signed it? Please take it back, and then whoever haven't signed, please come here and sign.